distributed applications need to know the entire system state. However, it is not possible to capture the states of all the nodes in the system at the same time. The clocks are usually asynchronous in the system, and the message delivery usually causes long delays. Global snapshot is the set of saved system states captured by each process as shown in the right figure. The black boxes in the figure shows the saved states by the processes. And we need distributed snapshot algorithms for the saved states to be consistent. Consistent global snapshot should not contain any orphan messages which are sent after the snapshot of the sender and received before the snapshot of the receiver. The messages with the blue circle in the figure are the orphan messages. When we analyze the snapshot states, some messages which have never been sent are shown to be received. Also, the in-transit messages which are sent before the snapshot of the sender and received after the snapshot of the receiver should be saved.
Sorry, dear Tizin Park, can you start over again? Because I missed the save the session.
So
please.
Do I have start from the beginning?
Yes.
Okay. Is there any problem in my speaking, the voice or sound?
No, I missed the saving session.
Oh, okay. Then
okay.
Can I start? Okay.
Yes.
Okay. Okay. Good afternoon. I am Taesun Park from Sejong University, Korea. Today, I'm going to give you a talk about distributed snapshot algorithms for a large-scale distributed system. Many distributed applications need to know the entire system state. However, it is not possible to capture the states of all the nodes in the system at the same time. The clocks are usually asynchronous in the system, and the message delivery usually causes long delays. Global snapshot is the set of saved system states captured by each process as shown in the right figure. The black boxes in the figure shows the saved states by the processes. And we need distributed snapshot algorithms for the saved states to be consistent. Consistent global snapshot should not contain any orphan messages which are sent after the snapshot of the sender and received before the snapshot of the receiver. The messages with the blue circle in the figure are the orphan messages. When we analyze the snapshot states later, some messages which have never been sent are shown to be received. Also, the in-transit messages which are sent before the snapshot of the sender and received after the snapshot of the receiver should be saved as channel states. The messages with the red circle in the figure are the in-transit messages. In order to discard the orphan messages, the snapshot should be taken by the processes as shown in the right figure. If we assume the in-transit messages are safely saved as channel states, the right figure shows a consistent global state since there is no orphan messages. So we can see the change, the point of the state saving. Our first algorithm requires all the processes in the system to participate in the snapshot coordination. The Marco message, which is the snapshot initiation message, is delivered to the processes through the channels. the processes only accept the first message and reject the redundant initiation messages. So the delivery of the Markov messages forms a spanning tree. The ACK messages are collected from the leap processes to the initiator process. Finally, the commit messages are disseminated from the initiator process. In the left figure, the arrow shows the coordination requests which are replied by the ACK messages, and the dotted arrow shows the coordination requests which are rejected by the NACK messages. In the right figure, the dotted arrow shows the Markov message. If the processes P3, P4, and P5 take their snapshot on the receipt of the Markov messages, at the point marked by the stars, the snapshot may be inconsistent. So we use messages with a marker. While the coordination is going on, the processes attach the marker to their normal messages. If a process receives a messages with a marker, it takes part in the coordination before processing the message. As a result, the processes can take the snapshot at the red boxes, which form a consistent global state. As shown in the figure of page 6, no open messages can happen using the marker attached in normal messages. Also, for the channel saving, every outgoing message carries the snapshot number of the sender. Using this snapshot number, the in-transit messages can be easily identified. The message M4 and 5 carries the snapshot number 4 in this example of the right figure. When the snapshot number of the receiver is now 5, so the receiver easily detects those in-transit messages, comparing the snapshot numbers, and save them as a channel states. The second algorithm works in a similar way to the first algorithm. However, the processes in this algorithm send the Markov messages only to the processes which have communicated since the latest snapshot coordination. One notable point is that when a process receives a message carrying a marker, it saves its current state as a tentative check snapshot. However, it does not participate in the coordination because these processes may or may not need to participate in the coordination. The messages M7 and M5 in the right figure carry the marker. On the receipt of this message, P4 and P5 take tentative snapshot. P5 eventually receives the Markov message and participates in the coordination marked by the star. In this case, P does not take a new snapshot at the point marked by a star. Instead, it uses the tentative snapshot. However, P4 does not participate in the snapshot. Actually, P4 did not participate in the snapshot. In this case, P4 can safely discard the tentative snapshot. Since the snapshot number 4 of process P1, P2, P3, and P5, and the snapshot number 3 of process P4 and P6 form a consistent global state. Since only part of the processes participate in each snapshot coordination, snapshot numbers of the coordination participants cannot be the same. Hence, during the coordination, the maximum number is chosen for the new snapshot number. Some messages sent during the coordination may carry the number smaller than the final snapshot number. To identify these messages, the messages also carry the snapshot state, such as white, denoting normal state, and red, denoting coordination state. So the messages carrying the white state and the snapshot number less than the snapshot number of the receiver are saved as a channel state. As a conclusion, we have proposed two snapshot algorithms. The first one uses snapshot number to identify in-transit messages. So the extra coordination messages for the channel saving can be reduced. The second one forces only the communication-related processes are participate in the coordination and also exclude the processes which communicate during the coordination. So the number of processes participating in the coordination and also the height of the spanning tree can be reduced. Thank you for your attention.
Thank you for your presentation. Dear participants, do you have any question about this paper? Okay, no questions. Thank you again. I wish you success, dear Tizin Park.
Thank you.
Next paper belongs to dear Alexander Turovsky. Are you ready to present? Dear Alexander Turovsky. Next paper belongs to dear Sarmat Mahmud. Are you ready to present?
Yes, I'm here, sir.
Okay, if you are ready, you can start your presentation.
Okay, thank you.
You have 10 minutes, please.
Okay. Excuse me, can you see my slides?
Yes.
Okay. Thank you very much for this opportunity. This is your presenter, Sarmat Nozad Mahmoud. I'm going to present my accepted IEEE article, which has the title, Study of Substrate Materials Impact on Compact Antenna Performance. I'm going to start with the outline shown here. I'm going to start with a brief introduction, a compact of miniaturized antennas, and summary, and talk about conclusions. Firstly, about the introduction, a brief introduction. Improving bandwidth and reducing size are important design aspects for compact antenna applications. In this slide, in order to reach wideband and decrease the scale of different microstrip antennas, there are several strategies we have to take into consideration. We always consider the size, dielectric constant, loose tangent, and the thickness of substrate materials. These kinds of factors affect on the performance of the antennas. I mean the performance like bandwidth, gain, radiation efficiency, and specific observation rate, which is the part that affects on the human body. I mean the radiation that affects and absorbed in the tissues of the human body in 1 gram of tissues and 10 gram of tissues, which should be always less than 2, according to the Federal Communication Committee, FCC. So most popular technique use a high dielectric constant of the substrate material to reduce the size of the printed antennas. I'm going to talk about different works given on compact and miniaturized antennas. I'm going to start with Afrin. They designed a compact planar inverted F antenna. They used FR4 substrate material. They started working on this antenna and they could work it on the applications of ISM because they have got or obtained low SAR value. This work was a good candidate for wireless body area network applications. Then Depoli designed a planar ultra-wideband antenna with slotted substrates. They used FR4 substrate material. Then they have got better and broad bandwidth. The antenna again used in the WBAN applications. Then Depoli again designed a tiny ultra-wideband antennas, again using FR4 material. they use it in, they have got triple band notch characteristics. Such kind of antenna has been used in wireless body area network applications, and they have got these applications with a higher frequency were slightly altered due to the fabrication errors. Another one, Rahman has designed a small band notch using a Roger material. This one was suitable for ultra-wideband applications. The antenna had a good radiation efficiency with better gain. However, a slight change from the simulated response at a higher ultra frequency was available in this design. Then Samal started designing a small textual felt antenna, substrate antenna, using they were used in ultra wideband for wireless body area network, and this one has positioned in the human body. We call it on body situation. They have used different. They have studied different kind of bending situations. I mean, when the patient, if we are talking about the patients where for detection of tumors or breast cancer, they can bend over all the time with comfortably with different bending degrees. The antenna obtained lower SAR values. Thus, again, design a lightweight on-body antenna using a Roger substrate in order to reduce the impact of the body stretching and glue swashing on the antenna construction. This antenna has used a new kind of feeding technique. We call it coplanar waveguide, CPW fit. This one can always give better bandwidth and better matching in air. However, reliable matching technology was required to produce greater bandwidth. Then Hamacher designed a small ultra-wideband antenna using Jorate with 3 L-shaped slots for notch band characteristics. This antenna achieved larger bandwidth, and they, however, employing the ground plane had limited the frequency range. Lackert designed a lightweight, again using a kind of feeding technique. This is a new kind of feeding techniques. We call it coplanar waveguide CPW fit antenna, but using Teflon material. In that one, they have achieved triple features across the overall bandwidth, but the antenna, again, used in applications of WiMAX and wireless LAN applications. Then Fang designed, again, using the same feeding technique, coplanar waveguide lightweight portable antenna constructed on ceramic materials. Actually, it is a flexible kind of substrates. The antenna produced better bandwidth, and it was robust against bending defects. I mean, they could bend the antenna in different degrees. This antenna was ideal candidate for portable devices. Sharma designed a small MIMO antenna. When we talk about MIMO, this means that we are talking about different kind of elements that could be neighboring to each other, and they are close to each other. So that's why when we have to always think about isolation, the isolation between the parameters of the antenna or the elements which can affect with each other. I mean, when someone sent a message, a signal, another one can receive without making interference between them. The antenna worked in a higher frequency band with better isolation, and the antenna was suited for wireless LAN and ultra-wideband purposes. Here is the summary of the works that I have presented. We concentrated in the summary on the antenna size, which is different, as we can see here in the antenna size with different materials, substrate materials type, and dielectric constant, loose tangent, and the thickness, we mean it H, and we have given in all of them in mm, and the frequency band. And again, we are talking about SAR that I have said about Federal Communication Committee, which should be always less than 2 according to the standardizations. Finally, as a conclusions, this article summarized the performance of different compact flexible antennas Microstrip patch antennas are frequently designed with low profile, low cost, and compact sizes. The most critical works has focused on the development of compact size antennas. Many applications that require higher bandwidth are becoming smaller and more innovative. Most techniques that shrink printed antenna size occurs using high dielectric constant of the substrate. As a result, the wavelength and the patch size are relatively reduced. The structural dimension of the design is reduced as a result of larger optimization and keeping optimization until we get the optimum way of the design. Duration of the antenna slots reduced in a size of range 10 to 20%. Thank you very much.
Thank you for your presentation. Dear participants, do you have any question about this paper? Okay, no question. Thank you again. I wish you success in your career.
Thank you so much.
Next paper belongs to dear Hüseyin Muhammed Ali Hammud Al-Wakel. Are you ready to present? Dear Hüseyin Muhammed Ali. Okay. Next paper belongs to dear Ali Saadun Ahmed.
Yes.
Okay. If you are ready, you can start your presentation.
Good evening. I'm Amna Nazar Jabbar from Altenbosch University. I'm here instead of Ali Saadun because he has another presentation.
Sorry, you have 10 minutes, please.
Yes. Detection of COVID-19 classification using classification of an X-ray image using Sniper. Introduction. COVID-19 is an infectious disease that occurred in Wuhan, China in December 2019. The coronavirus separated from person to person repeatedly all over the world. This virus can cause disease such as a severe acute respiratory syndrome. The total case number of coronavirus case is almost 335,403, while 95% of infected patients survived in some form. 5% of the remaining patients have serious or critical condition. An increase in COVID-19 detection leads to an increased need for intensive care. Even in developed countries, this can lead to a collapse of a health system. This works classify chest X-ray image of 1,200 patients with COVID-19 and 1,200 healthy patients using the KNN algorithm. Methodology. The first step in this process of classifying image is process of extracting feature from digital image. These features are based on which a classification model is made. After this step, the design model is built, which depends primarily on the measurement of distance between the image feature will be extracted, and then finding the lowest number found in the value by arranging the value in ascending order and choosing an odd number for this value. And thus there is a number better than other number. The image classification technique is represented by several steps as shown in the figure. First, we input the data set, then extracting the features, then it's input in training and testing stage, then it's evaluating and classification model is building. Image feature extraction. In computer vision, we employ a variety of classifiers, each with their own set of properties and attributes. Feature extraction is part of the process of dimensional reduction. It's helped to get the best feature from a huge data set by selecting variables and combining them into features. Selecting variables and merging them into features make it easier to extract the best feature from large data set. The local binary pattern is an easy to use and effective feature extractor. Local binary pattern's main objective is to extract local features that will be improved globally characteristic to identify the pixel of an image and encoding the local structure around each pixel. The original local binary pattern operator employed decimal value known as local binary pattern or LBP codes. The operator assigned a label to each pixel in the 3x3 neighborhood of each pixel by 3 shading, as shown in the figure 2. By subtracting the center from the center value of a pixel in 3x3 close by and then representing the ensuing number as a binary integer. Each pixel is compared to 8 of its neighbors. The histogram of oriented gradient. Hawkes features a descriptor computing by sliding a window detector over an image have been successfully used for object detection because they representing an object as a single value vector rather than collection of feature vectors, each of which representing different region of the image. This is accomplished by segmenting the window into tiny spatial area or cells with a local histogram of one dimension gradient direction in each cell. The original gradients histogram, the oriented gradient histogram approach for feature extraction combine the pixel accurated with the histogram which detective distinctive characteristic. Image classification using KNN. The K-NAIR sniper algorithm is a simple, easy to implement supervised machine learning algorithm that can be used to solve both classification and regression problems. The KNN algorithm assumes that similar things are existing proximity. In other words, similar things are near to each other. The K-NAIR sniper algorithm is a technique used for categorized objects using the feature space closing training samples. The KNN algorithm steps. 1. We load the data set. 2. Set K to a desired number of neighbors. 3. For each data point in the data set, 1. Computing the difference between the QRR, the data points that are currently available. 2. To an ordered collection, add a distance and index for that data point. 4. Sort the ordered list of distance and index from last through largest distance in ascending order. 5. From the sorted collection, choose the first K element. 6. Obtain the label from the K entry that you select. 7. Get average of the K label if regression is true. If categorization is required, return to the K label model. Euclidean distance. Euclidean distance calculate the distance between two value vector. Euclidean distance is calculated as a square root of the sum of the square difference between two vectors. Experiment result. The experiment features are used in the classification process and are used for building the classification model for COVID-19. The process method was applied to the data set that contained about 2,400 X-ray images. In the figure, it's the sample of normal and abnormal chest X-ray image. For evaluation of the classification result, the KNN was used. The results were tested on the average of samples taken random 2,000 images. Each time, the measurement of multiple training ration 50%, 60%, 70%, 80%, and 90%. All measure related to the confusion matrix such as accuracy, error rate, sensitivity, false post rate, specificity, precision, and prevalence for two types of classification as shown in table 1 and 2 for two types of using features, local binary pattern and histogram of oriented gradient with the algorithm K-nearest Sniper. The table 1 for the local binary pattern with K-nearest Sniper shown in the different sides of training show the accuracy, error rate, sensitivity, false post rate, specificity, and precision and prevalence. The table 2 show the histogram of oriented gradient with K-nearest neighbors with different sides of training rates. Show the accuracy and error rate, sensitivity, false post rate, specificity, precision, and prevalence. Conclusion. In this paper, training a device on dataset of X-ray image of people with COVID-19, the condition can diagnosis using imaging only. There are approximately 2,400 images that are evaluated, and the results are obtained from different groups of random samples chosen from the total number of images from a number of iterations using variety of training size ranging from 50 to 90%. All the calculations that were performed, including those from accuracy, error rate, sensitivity, false rate, specificity, and precision. Come accuracy. Thank you for your listening.
Thank you for your presentation. Dear participant, do you have any question about this paper? Okay, no question. Thank you again, dear Amina Nazar Jabbar. I wish you success in your study.
Thank you very much.
Next paper belong to dear Raul Parga Hermida.
Yes, I'm in here.
Okay, if you are ready, you can start your presentation.
Okay.
You have 10 minutes, please.
You are showing my, are you seeing my presentation?
Yes, we see.
I'm going to put in, thank you very much. I would like to thank the organization for the opportunity to publicize the research I'm working on as a doctoral student in the I3M program at the University of La Laguna in Tenerife, in Spain. First of all, I want to give you a description of the location and the environment in which this study was carried out. Tenerife is in an island in the Atlantic Ocean belonging to the Spanish autonomous community of the Canary Islands. The Canary Islands are an archipelago located in the Atlantic Ocean that forms a Spanish autonomous community in Northwest Africa. With the status of a historical nationality, it is also one of the outermost regions of the European Union. The predominant climate in the area is subtropical oceanic. The location of the island of Tenerife is determined by the coordinates that appear on the slide. Here is our localization. The island of Tenerife has an area of around 2,000 square meters and a population of almost 1 million inhabitants. On the island is the highest volcano in Spain with an altitude above sea level of 3,715 meters. The island has a complicated orography with up to 221 drainage basins. The annual rains are not very important on the island, but torrential episodes like the one I want to show you with the following video, corresponding to February to 2010, usually occur. I'm going to share a video if I can. Sorry, I'm going to put it into the. This is the ultimate runoff in a basin in 2010. You can hear the comments for the people in the neighborhood. Well, I think it's enough to see the phenomenon. The basin of the Barranco de Santos is one of the largest on the island of Tenerife. The channel has its source at 900 meters above sea level in the mountain of Las Mercedes and crosses the Vega de la Laguna, descending towards the sea bordering the mountains of Anaga to the southwest, and finally flowing the dock of Los Llanos out of the port of Santa Cruz de Tenerife. Its main channel of more than 16 kilometers has sections in which it becomes a real canyon with cliff walks on its margins up to 100 meters high. From the collection of rainfall data from mentioned date, February 2010, that were collected in the different rainfall stations that we find in the slope basin of the Barranco de Santos, and topographic data of a section of its main channel at the height of the Serrador Bridge, a hydraulic model has been made by means of which to simulate the theoretical height that the water seat would reach in the section of ravine model for the theoretical runoff flows obtained by the methods of the synthetic unit hydrograms of Schneider and Triangular. Subsequently, it will be tried to compare these theoretical results with the real images that are available of the flood in the location where the model has been made. There is another official method for calculating runoff flows on the island of Tenerife, the methodological guide for the calculation of avenue flows on the island of Tenerife. This is a computer application you can use to enter manually the coordinates of a point from which we want to know the runoff flows for different return periods. By entering these coordinates, the aforementioned computer application shows the watershed at that point and presents a report detailing the runoff flows and daily rainfall for different return periods using the unitary synthetic hydrogram of the Soil Conservation Service of the United States Department of Agriculture method. Unfortunately, the runoff flows provide are for some rainfall data that it has within its database, not being able to enter in addition to the coordinates of the point where we want to calculate the runoff flow, the rainfall for which we want to calculate said runoff flow corresponding to February 2010. The Schneider synthetic unit hydrogram is useful when the necessary historical flow and precipitation sets are not available for the deduction of the unit hydrogram of a basin. The deduction of the parameters for defining a synthetic unit hydrogram is based on the geometric and morphological characteristics of the watershed. These are the formulas used where you can see that T sub P, the basin delay time in hours, C sub T and C sub P are dimensional coefficients with values that depends on basin inclinations, more level, L, the length of the main channel, L sub C, the length from the point of the main channel closest to the geometric center of the locations to the point under consideration, L and N sub C in kilometers, and the peak flow rate of the Schneider unit synthetic hydrogram per millimeter of net rainfall is determined by the formula shown in this slide, where A is the drainage area for the basin. The theoretical foundation for the estimation of the triangular synthetic hydrogram determined a peak flow in cubic meters per second and per centimeter of net rainfall, depending on the area of the basin and the base time in hours, according to the show expressions. The base time depends on the D sub E, the duration of excessive rainfall in hours, and T sub P, the delay time of the peak flow in hours depends on the concentration time of the basin. The concentration time of the basin, T sub C, depends the concentration time of the basin T sub D understood as the time it takes for a drop of water to travel the path between the farthest point of the basin and the control point is determined according to the formula exposed in the slide, where L is the length of the channel in kilometers to the control point and I is the average slope of the channel. The theoretical peak flows calculated by various methods, in principle applicable to the island of Tenerife, do not give uniform results, how you can see in the slide. If we compare the graphs corresponding to the hydrograms that would be generated by the methods of the synthetic unit hydrograms of Schneider, these in red and green, with the synthetic también also triangular with that this in orange and this other with the compares with that generated by the methodological guide for the calculation of flows on the island of Tenerife, it can be observed that neither the time in which the value of the peak flow is produced nor the base time of the hydrogram are coincidental. This makes us wonder why on the island of Tenerife is it more appropriate to consider the method of the unitary synthetic hydrogram of the Soil Conservation Service of the United States Department of Agriculture as established by the methodological guide for the calculation of flows on the island of Tenerife, or what would be the most appropriate method to determine the value of the theoretical peak flow and its distribution over time within the basin under study, or wouldn't it be more appropriate to make a tailor-made suite by watershed that is to determine the peak flow and its associated hydrogram in a particular way? In order to give some kind of answer to these questions, it is understood that it is necessary to analyze real values of rainfall and runoff flows associated with them in the location under study. We have real rainfall data for February 2010, but not runoff data. We do have images of the previously shown video about the flood of February 2010. For this reason, a hydraulic model has been created by HEC-RAS. This is a computer program developed by the U.S. Army Corps of Engineers to perform one-dimensional and two-dimensional calculation for a complete network of natural and built channels. We can do simulation with this model from the rainfall data for February 2010 and compare them with the real images in order to see which of the theoretical methods used to calculate runoff flow is closest to reality. Like conclusions, I need to say that it is not advisable to adopt theoretical methods for calculating runoff flows without having previously calibrated them. For this, it will be better to analyze real rain values and runoff flows associated with them through the implementation of equipment that allows measuring set flow. With equipment that can measure the water level in the channel and the speed of each surface, we will be able to calculate the flow that circulates through the section under the study. Thank you very much for your attention, and that's all from my side.
Thank you for your presentation. Dear participants, do you have any question about this article? Okay, no questions. Thank you again. I wish you success in your study.
Thank you very much.
Next paper belongs to dear Elaf Alabet. Are you ready to present? Next paper belongs to dear Ali Hussein Olevi Al-Muhtar. Dear Erdeniz Erol.
Yes, but I have presented. I am present because he is a
Okay. You can present if you are ready.
Okay. What's 1 minute?
You have 10 minutes, please.
Okay. I agree with you.
You can share your screen.
Do you see my presentation?
Yes.
Hello, and my name is Emin Güney. This presentation is about electric shortship charging socket detection using image processing and YOLO methods. We investigated this charging problem for electric ship to shore socket with a method that is HSV and YOLO methods. Okay, these presentations contents is included. Firstly, I mentioned the introduction part. After that, literature review and some issues about this paper. After that, proposed system architecture and systems application interface. Finally, I discussed means to experimental results, and finally, I ended with this paper to discussion. Okay, when we looked at the literature review, we can see that the ship's socket charging problem is a new problem that developed in the after 22 years, and the production of electric and hybrid vehicles on land and the sea is now widely used to reduce carbon emission. Generally, we all about the now this issue, these topics. While charging the batteries of electric vehicles can be done manually, studies to automate this process are increasing. For this purpose, in this study, we can discuss and we can propose a method for a new problem. Actually, the YOLO and HSV techniques is popularly used, and the problem is new. An interface has been developed for the detection system of electrical charging system sockets by using classical image processing methods of HSV and the YOLO techniques, which is one of the deep learning methods. With the Delta interface, we can detect the socket's position and monitoring in real time through the image taken from the camera. Thus, automatic charging can be performed successfully. Yes, we summarized this study is a matter, three matters. In this study, we performed a real-time computer vision and YOLO-based detection of the female socket on the ship with the camera located at shore charging stations. Secondly, in addition, we compared the two methods according to success and variety based on YOLO and YOLO V4 and HSV computer vision methods. It's aimed to show the performances of these two methods in real time, real test scenarios. When we look at the various studies on object detection and tracking, monitoring, or based on computer vision and actually YOLO exists in the literature, we can see these studies, and I summarize these studies. Firstly, Radovic et al. Performed CNN training on various aerial images for automatic object recognition. The system's efficiency has been proven with an accuracy of 97.5% in the detection of objects. It is an actual good performance, but it is not implemented on the ship socket detections. It is only detection, object recognition. Kagan et al. Proposed an innovative HSV color space-based system that can automatically extract object position information. Experimental results prove the high performance of the proposed system. Thirdly, Barry et al. Achieved a rate of 0.14 frames per second FPS for the real-time object detection for constrained resources, for example, GPU devices like Raspberry Pi or Jetson Nano. The proposed approach mentioned its success in terms of speed, especially in embedded platforms. Misekis et al. Implemented a 3D image guided robot-based charging station for plugging in the charger in electric and hybrid vehicles. They present a system concept consisting of a 3D computer vision system, UR10 robot, and a charging station. Hayes et al. Evaluated different charging technologies for use in the industrial environments and presents a new approach for automatic robot-controlled charging of electric vehicles based on a standard charging interface. What's about this paper? This study presents the real-time computer vision and YOLO-based detection techniques for the detection of the female socket on the ship with the camera taken of the PLC systems located at shore charging stations. The intelligent system can aim and can realize automatic charging in real time by combining the mobile male socket on the shore charging station with the fixed female socket on the ship. This study uses two methods, as I mentioned. Firstly, HSV, and after the YOLO, and comparing results this paper presents. First of all, HSV color space is used to detect and recognize the position of the female socket on the ship, which enables the system to work without the need for training. Then the system was trained with the YOLO V4 model for faster and more accurate detection of the female socket. And we can see the proposed system architecture from this image. The color space method is classical method that can be applied faster without needing any data set. We don't use any data sets in the HSV color space method. We only use computer vision functions and methods. It was used in the study because it doesn't require training and it's faster and easy to apply. The flowchart summarizes this section in Figure 1. The algorithm in this diagram can be easily seen. Sharding files to start or not start according this starting part. It is designed. We designed this system. Flowchart summarizes this section in Figure 1. In general, in this method, the X, Y, and Z coordinates of the fixed female socket on the ship. We can see this from this image. It is taken from the ship. It is combined with ship, this socket, and shore. And at the shore, a male socket combined this with this charging socket, and after that we start the charging operation. Yes, the flow diagram in Figure 1 shows that the video image taken in real time with the camera is first divided into frames with these resolution images, classical resolution images. Each received frame is reduced by 16% for the system to run faster. We applied the methods on the videos, and we applied these computer vision operations. Figure 2 shows this our operations, morphological processing steps, original image from a green filter. We applied the green filter. After this image, double closed image applied. We applied this method and some operations to detect two red squares. And we use the YOLO method after HSV method. We aim to show YOLO algorithms superiority. Another method used in the optimization of the study is the YOLO architecture, which gives more reliable and fast results. Boschowski et al. Have proposed YOLO V4, which has some significant changes from YOLO V3, as you know, in terms of speed and accuracy. You can see the YOLO network architecture from this image. YOLO consists of two different stages that occur simultaneously. YOLO needs the data sets for training and testing of the model, and we collected the data sets, and these two figures shows the sample images from data sets. We collected these images from the laboratory for the realizing two experiments, and found some illuminous environments and some closed environments, closed air and open air environments we collected, and we created the application interface, as you know, development systems interface. First of all, we log in this panel and we select this one, HSV or YOLO, for the detect charging socket, female charging socket. After that, if we select the HSV method, we can see this panel, and if we select the YOLO, we can see this panel with the accuracy rate, and the system calculated the distance of the object which is charging female charging object from the image. It's calculated, and after that, figure 7 shows the model's loss curves along with accuracy. In figure 7, the red curve of the graphs shows the model's accuracy. You can see this from the image, and we calculate real-time socket detection test results with these perceptions and IOU intersection of union, and approximately 100% mean average precision MAP. And the results and decisions parts. The introduced system can realize automatic charging in real time by combining the male socket on the shore charging station with the fixed female socket on the ship. HSV color space is used to detect and track the position of the female socket on the ship, which enables the system to work without any. Sorry. Do you have any question?
Thank you for your presentation.
Thank you.
Dear participant, do you have any question about this paper? Okay. Thank you again. I wish you success in your career.
Thank you. Thank you.
Next paper belongs to dear Huda Abbad. Dear Huda Abbad, are you ready to present? Last paper belongs to dear Sheriff Aspiro.
Yes, I'm ready.
Okay. You can start if you want.
Okay.
You have 10 minutes, please.
You can see my presentation.
Yes.
Okay. Hello, everyone. Thank you for organization this conference. My name is Sherif Aspiro. I'm studying in on the Kuzmais University in Electrical and Electronic Engineering. My paper in title an experimental study of the effect of different genetic algorithm operators on coverage using heterogeneous nodes. With the increasing interest in coverage in various fields such as military or environmental matters, the need has increased to improve the deployment of a wireless sensor in a way that ensures the presence of the least number of sensors and maximum coverage. In this paper, we will present an experimental study in solving the problem of maximum coverage over a two-dimensional space and in the presence of heterogeneous nodes containing different sensing ranges using the genetic algorithm. We will study the various parameters of the genetic algorithm such as selection, crossover, and mutation methods. Finally, we will compare the results that give the best coverage. Let's talk about the related work. The studies that used the genetic algorithm to improve coverage varied, and the difference between these studies were changing the algorithm operators, adding other algorithm and the sub-factor in previous studies, or merging previous studies to get better coverage. Some preparatory factors have been added to facilitate the use of algorithms such as Voronoi diagrams in first reference. In another study, the issue of maximum coverage for sensor of the different radius was investigated using the genetic algorithm that was modified and give 5 different versions of it, namely PGA, MGA, OPTGA, and OPTHGA. Lee et al. Developed the last one, OPTHGA, and named the new algorithm IGA, and achieved better results in terms of time saving and solution quality compared to OPTHGA. Han et al. Found that the result obtained from the IGA algorithm was unstable. Therefore, they paid attention to the stability of the algorithm, not to the issue of time complexity. Zorlu et al. They study the issue of increasing coverage using homogeneous and heterogeneous sensor through a modified fitness function. Gupta et al. Assumed that sensor may not be suddenly active, so they focused on the concept of K coverage and K connectivity. Our problem formulation in this way, we achieved
Sorry, but you don't forward the slides pages.
Sorry, I didn't understand.
You are not forwarding these slide pages. We are still on third one. I guess you are talking about the other slides.
This one.
I don't think so.
Anlamadım.
Ya tek bir slide'da kaldın da ilerletmeyi unutmuyorsun değil mi dedim.
İlerletmeyi unutuyorum. Yani ilerliyorum ben şimdi de tam anlayamadım da. Şimdi ilerlemiyor mu?
Evet, demin ilerlemiyordu. Evet.
Nasıl yapayım? Şimdi iyi mi? Şimdi oldu mu?
Evet, şimdi
Şöyle.
sen 5. slide. Evet, şimdi oldu.
Tamam. Okay. Sorry about that. Now I will böyle devam edeceğim. Kusura bakmayın. We achieved the largest coverage by using this heterogeneous sensors at UC. Each color represents a type of a node. The purpose of our study is to provide an analysis of the genetic algorithm that is used to solve the problem of maximum coverage. And we have chosen the heterogeneous nodes, so we used the conditions found in literature mentioned in 2 and 3 and 5, which presented as follow. K is the number of sensor type, and the number of sensors, Ni the number of sensor for type, where I is 1, 2, K as follow. Ri is the sensing radius of sensor type. W and H, the width and length of the two-dimensional field. We assume there is a two-dimensional monitoring area, and that there are K number of sensor. Each sensor has a sensing range of radius Rs. We assume there is a sensor Si at point Xi and Yi, and for any point P in this region, in this way, we can calculate the Euclidean distance D between SI sensor and P point, which is equal to, in this formula. The most used model in literature that is also used in our study as an evaluation method was the ball and disc coverage model, as in which formulated mathematically as follow. if the distance between the point and the center of sensor is less than the sensing range according to this formula, this function, it will give us the result 1. Otherwise, it will give 0. Genetic algorithm. We use the genetic algorithm to increase the coverage in the case of heterogeneous nuts with different radius, and we tested the different operators of the algorithm. We started the algorithm with a random initial spread and of the nodes, and to select this parents, we tested the roulette wheel and tournament method. We used 6 types of crossover: 1 point, 2 point, uniform, PLX alpha, arithmetic, and min-max arithmetical. In addition, in this way, random mutation method was used. Then we tested 4 types of mutation: random, swap, invert, and scramble, while running 2 methods of selecting parents, each one separately. Genetic algorithm flow chart. Firstly, we will start, then we will do the population initialization, then evaluate the fitness of each chromosome, then we select the parents, and then we do crossover operator, and then we do a mutation operator. Lastly, we evaluate a new generation and check stop criteria if the current generation less than maximum generation or not, and then if yes, stop. If no, then back to selection. Genetic algorithm. When preparing the population, we put the initial population number represented by the chromosomes, and the genes inside this chromosome are data for the coordinate of sensors, and we can express them as in the figure below, where each color express the type of node that has different radius. Selection method. Let's talk about this selection method, roulette wheel. This method of choosing parents depend on the probability of selecting good parents according to the value of their fitness function. On this basic, PI is the probability of parent I to be chosen, and the individuals with the greatest probability are as shown below in this way: fitness of I divided by total of fitnesses. Tournament selection method. In this method, we selecting a specified number of individual randomly, and then comparing their fitness and selecting 2 individuals who have the best fitness to the next step, as the figure below. Maximum fitness it has will selection after randomly selection. Crossover operator. 1 point crossover. We choose selecting a random point in the chromosome of each parent, like this, that it's within the domain. After the first genes and before the last gene. After selecting the point, the chromosome data will be exchanged as integral below in this way. This parent 1 and parent 2 and child 1, child 2, it will be exchanged. 2 point, the principle of this method not different from the previous one. This method can be generalized to become K point, but in our study we choose 2 point. Here we specify 2 point in the same field that we mentioned earlier. After the first gene and before the last gene 1, genes are exchanged to become like in figure below. The same color is first child, and the another color, the second child. Uniform crossover. The principle of the uniform crossover is based on the inheritance of entire genes from the first parent or the second parent, and what determines this is a probability of choosing number between 0 and 1. This number, random number, is compared with the probability of crossing over. If it is greater than the probability of crossover, the child takes the genes from the first parents and vice versa. In some cases, a masked gene is used that contains genes consisting of 0 and 1. If the masked gene is 1, the child takes his genes from the first parents, and if it's 0, the child takes the gene of the second parents. Arithmetic crossover. As we know that the parents are chromosome that contain genes in this way, parents 1 and parents 2, he have genes. Child 1 and child 2 in this formula, beta times parent 1, first parent, plus 1 minus beta times parent 2. And same thing in child 2, where the beta is between 0 and 1. Here I is equal to from 1 to n. N is a number of sensor. Max minimum arithmetical crossover. This method is an upgraded version of the previous one of the arithmetical. 4 children are created from the parents, and 2 of the best are selected according the value of fitness as follow. Same thing, there is the formula, and these two child, we choose the maximum and minimum, and then we will select it according the value of fitness they have. BLX alpha crossover method, the last one. In this method, after selecting the parents, the genes are arranged according to highest value and lowest value in this form of 2 chromosomes. And the difference between the 2 chromosomes is taken, and then the value of the children are taken randomly from the interval mentioned below. Same thing, we have the formula. This formula we take it to create offspring or childs. Mutation operators. We did 4 version of mutation operator. Random point. Random point. After crossover process, we make the mutation to ensure that no identical individual are produced, and the probability of this mutation is very small. This process is considered the most widely used and gives good result. The principle of this process is to change the value of the random genes from the genes of individual and give it a new value that is commensurate with the studied problem. In our problem, we know that the gene is made up from of X and Y coordinate. So we will produce coordinate value of them that do not conflict with our problem, that they don't go outside the set limits. We will call this method a random point, and we will represent it in binary for easy to understand like this. We have one before and after. Before mutation, we have genes, and we chose randomly one, and we will exchange it 0, and then it will be 1. Swap mutation method. In this method, we swap the location of 2 genes inside chromosome as shown in the figure below, 0.5 in here and 0.9 in here. Inversion mutation method. Here we selected random invertal from the gene of the chromosome and reverse the order of the gene. We will start from here, 5, 4, 9, 1, and after mutation, the values started from this point, 5, 4, 9, and 1. Last one, scramble mutation method. We choose the random invertal from the genes and of the chromosome, and we scramble the position of genes. Experimental results. We used field with an area of 100 by 100. We used the values shown in table below in genetic algorithm. Population number, we take it 10, a number of alike 2, crossover probability 0.5, mutation probability 0.1, and iteration number is 100. As the sensor range, the number sensor, we used the data after several trial. This was the best as shown in the table below. First, type of radius is 14, and the number of sensor is 6, and same thing to other groups. We programmed the genetic algorithm and applied it to heterogeneous nodes. So we used the different algorithm operator, and the equation for we have C was a fitness function. This one. This one. This is the fitness function. What the fitness function and calculate the percentage coverage for each condition. We installed the random mutation method and tested it to the 2 selection method with all crossover method. We went back and calculate the coverage by installing a 1-point crossover method and testing methods of selection with the 4 mutation methods. Then we run the program 30 times for each condition, calculated the mean and start division values, and mentioned the best time the program was run. In this case of testing the crossover operator with the rolled method in figure 10, we noticed the superiority of the 2-point method at the beginning, but it stabilized at the end, while the arithmetic and BLX alpha gave greater value at the end. On average, we found that the 2-point method gave the best value among other methods when used with roulette wheel. In this case of testing the crossover operators with the tournament method in figure 11, the superiority of the arithmetic appeared, although the BLX alpha started better and on average gave the best coverage value. When comparing the cases of mutation while using the roulette method in figure 12, we find that the best value were with the random point. As for the rest of the cases, the values decreased because the random point mutation gives a new value that greatly affects the work of the genetic algorithm, while the rest of cases have less impact. In last case of comparing the mutation with the tournament method in figure 13, we also note similar result with the previous case, except the case of inversion was slightly better than the random point. And the reason for this result, the low effect of random point method is due the randomness of the tournament selection method. This here we have the tables containing the data we got: roulette wheel selection, tournament selection with the crossover types. We have the mean, best time. We have run the program and start division, and we have here 2 selection method with mutation types. Conclusion, in this paper, we have used the genetic algorithm and tested it with different operator on heterogeneous nodes to calculate coverage. We have achieved about 10% improvement. And the best results among the crossover methods were arithmetic and BLX alpha with both selection method. In the case of mutations, we found that they are affected by the difference in the method of choosing parents. We found that the best mutation method with the roulette wheel selection method was the random point, but in the tournament selection, it was the inversion method. Also, the method produced promising results. Several improvements, such as proposing a hybrid algorithm or a new fitness function, can be performed for future work. Here, I leave the references, and thank you for your listening and your time. Thank you very much.
Thanks for your presentation. Dear participants, do you have any question about the last paper of today? Okay, thank you again. No question, I guess. I wish you success in your career.
Thank you very much.
The last session of today is over. Dear participants, thank you for your attending. I wish all participants continued success. I want to end the session. Dear participants, hope to see you at tomorrow's sessions. Good evening.
Good evening. Thank you very much.
Thank you very much.
Bye.
Thank you very much.